So come back around for that. Uh, Without further ado, Stuart, you're up first. Yeah? All right, give it up for Stuart, everybody.
Okay. Yeah, so this is going to be pretty fast, and I'm not going to go into a lot of the details, but we're going to talk about using Flexbox, which is in CSS3, and hopefully it'll inspire you to try it back at your place of work or home or whatever. So the very basics, Flexbox is just a way to describe a container, and that container, do you want to? Okay, so basically what Flexbox does is allow you to define a container. Anything can be a container. That's what's so great about Flexbox. It can be almost any HTML control, list, divs, input fields, everything. Images, they can all be containers. And in those containers, they can contain items. Now, another great thing about Flexbox is that containers can contain containers. So you get a lot of capability. So what we're going to do today is very, very quickly, we're going to create an input form, because why? We're programmers and we are creating forms over and over and over again. It's going to be really simple. It's going to have 2 columns of input fields and then a button at the bottom. So if you think about it, basically it's just a container with several containers inside of it. Now, the important thing to remember about Flexbox is that the way it works is that you have this main axis, and that's where you're going to justify your content. So think about main and justifying everything first. And then when you want to align things, you're going to align them against what's called a cross-axis. But don't confuse that with being strictly X and Y, because your main axis can go in different directions. So just remember your cross-axis is always perpendicular to the main one. So let's get with it. And the first thing I'm going to do, and I'm doing this one-handed, is we're going to create a form field, okay? Because remember, we've got containers within containers. Simply to create a container, you just simply type in this property, display, and then we're going to tell it it's going to be inline flex. I'm still going to use divs. Divs are still great containers. What made divs bad with alignment is people were trying to use floats. Floats are evil. Flexbox is good. So here, I'm displaying it on the right. Step 2, now we're going to add the submit button. So basically what we're going to do is we're going to create another class, and this one's just going to be display flex, and we're going to use that justify for the content, tell it to justify center. There we are. We have 2 containers. Now we're going to wrap them and add some more fields. So the next step is basically we're going to make our form the overall flex container. So we're just basically going to add some CSS to the form element. Here we have our form element. Now if you notice, by default, everything in Flex defaults to row versus columns, and by default things are going to wrap. So you can see here I actually have 3 fields, but that email field is wrapping around. So now we need to try to put things inside that column object so that they align correctly. So we're going to create another class called form column. Now what I've done is, if you look over here to the left, we have this div called form column. In it are 3 separate fields, and the next one are 2. So now the next thing we want to do is we want to make them go left and right. So what we're going to do is, and this is one of the great things about Flex, is if you just start thinking containers within containers within containers, you can justify and align many different ways. So here we're going to create a container for the columns which contain the input fields. Simple. So here you can see we have that container, and it's got our left column and our right column. Now let's put our fields back in. And this time we're going to use one of those align properties. So remember, we're going to tell it that we want everything to align on the cross axis on flex start, which is going to be on the left side. So that's going to make everything line up nicely. So here. Now we're getting close to what we want. So the only thing that's left is we need to make this responsive because why? Because people use phones all the time. So that's going to be pretty straightforward. We're just going to simply add a media query. And notice this time our direction is going to be column, which is not the default, versus row. And then we're going to align all of our content to the center. Over here to number 6, 7. And now we have a nice line. And what I'm going to do is I'm just going to zoom out real quick, just so that way you can see in this preview mode. I'm using Visual Studio Code, by the way. It's a great tool. I love this tool, especially if you're just wanting to do something quick and dirty. And last step, let's just dress it up a little bit. So take all those boxes out. I use those boxes, those borders, so I can visually see how my containers are lining up. So as you can see, we have our nice responsive form. And what's so great about this is that there's no bootstrap, there's no jQuery, it's pure CSS. Even you can do it. And so one last thing is, can you use this now? So unless you're really having to support older IE versions, you can use Flexbox now. And for a copy of those slides today, you can, or if you want to get the HTML, go to github.com, StuartDGA, Flexbox form. All right, thanks.
All right, thanks, Stuart. So I've got my time timer here. We'll use this from now on. And who's next? Next person will. It'll beep at you at 5:30, and you've gone well over at that point, so just keep an eye on it. All right. We'll go in order. If you know what the order is, we'll go in it.
All right, my lightning talk is going to be about a better tool I came across in the last couple of weeks that I think worked good for the command line, quick monitoring, and performance metrics checking. But since it's my 5 minutes and I'm not totally read yet, I'm going to promote the CHA DevOps next Tuesday night. We're going to do automated testing, have a presentation on automated testing. Josh Marlowe from Bellhops is the person who's going to do the presentation. I don't recognize Josh. Is he here? Okay, I wanted to say thank you if he was. So next Tuesday night here, we'll be in the large conference room, 6 o'clock. Okay, so there's a whole series of utilities you can use. Are you still using VMstat? Of course, that's the old perennial one. It's been around forever. Are you still using it? Stop it. There's something better. Are you still using NetStat? You got to know about your network I/O, right? If you are, stop that too, because there's something better. Are you still using IOstat? You got to know about input/output, right? If you are, stop that too. Anybody know what Star Trek episode except for Sean? He looked it up for me. What was it? There you go. Very good. Extra points. So what was this about? This is about I/O. Stop using that. IFstat. You got to know something about your interfaces, right? Guess what? Guess what the answer is? No, don't do it. All right. And finally, MPstat, multiprocessors. There's hardly anything out there with one processor anymore. You got to have something for that. MPstat's not the right way. Don't do it. So, if not them, then what? Right? DStat, to the rescue. DStat's a cool utility. I'm going to have to hurry up here. So here's the man page for DStat. It does all of that and more. It presents things in a nice, flow and in columns and colors, and it does all of that and a lot more. It's extensible. It has plugins. It's available for your favorite OS, the Red Hat versions or the Debian versions. These are just some of the things. In fact, these are the normal plugins that are written for it out of the box. There's other extended plugins that are there in the box, out of the box as well, and you can write your own. You write your own in Python. CPU and disk and paging is an important one to know about. Memory and network. Procs is very important to know about. Run queue, block queue, wait queue. Those are killers if you don't watch them. Swap is important. That tells you how things are going on memory. If you're swapping, you're not running well. Got not enough memory. The time is useful, especially if you're outputting this to CSV, and you can. This will all go to CSV. CPU use, some memory, sockets and raw stuff. So this is what it looks like. If you just run dstat out of the box on the command line, you get this. You get CPU, disk, network, paging, and system. If you run it with --vmstat, then you're looking at what you used to see when you saw vmstat, but I think in a much more readable and better presentation. These are some of the extended plugins where it'll show you the top CPU consumer, the top memory consumer, and you stack these up and they appear in the columns as you put them on the command line. This is an example of how to send the output to a CSV file. Roll your own. This is what I like to use. This is what I use to monitor a particular app that we have at work. So the VW just says, you know, show it better on a white screen. Proc and disk and net, and so this is what I like to use. This is the plugins go on and on and on and on and on. So there's a lot of plugins. This is an example of using some of the plugins. So you can see here that you've got your top CPU process for that particular tick, your top I/O process, your top latency. Then you can take the CSV, the output, and you can suck it into some sort of a graphing application, and you can get nice graphs. So all you have to do is take your favorite command line, you come up with dstat, tack on --output, the name of the CSV file. That goes to a CSV file. You can suck it to a spreadsheet and do your own graphing or use a graphing tool. I like to do this. I like to bundle it with Ansible, tell it to just get me 2 intervals, the average plus the current snapshot, run that against a group of servers, and it comes back and lets me know how my group of servers is doing. So I can see here that, you know, I'm pretty good on swap across 5 servers. I'm not paging, so that's a good thing. You know, my CPU is the idle is, you know, up there where I've got some idle CPU. So this is handy. Just match it up with Ansible. That works out great. And I think I'm about out of time. Let's see if we can demo. So there's dstat running, and I can see. And one other quick thing I can show you. Things change up the top here because the CPU goes up, so I can see that's happening. You know, so I've got some stress going on to show, and I've got that going to a CSV so that you could then suck that into something. Thank you.
QP. We're going to go in order now. Sit down, Craig. Have a seat, sir. All right. 5 minutes. Everybody give it for QP. Round of applause.
Hello, hello. So I make games for fun. You might make full screen applications as well using Node and Electron. I ran into something recently where I had everything set up to draw at a certain screen resolution. I realized, oh crap, people use different screen resolutions. This isn't going to work. So this is how to make something look okay at different resolutions. So in my, so this is my main. I'm using Electron, by the way. So this is Electron turns JavaScript apps, Node apps, into native applications. So in my setup, what I do is I get a primary display. Can you all see that okay, by the way? Cool. I get a primary display and work area size, and I get the width and the height from that. And then when I create my window, I have to pass in the param to the browser window width and height. This means that in my program, whenever so this is my code now. This is I have my engine client class for setting up the display. I require Electron at the top, and then what I can do here, and I've really tested this for square displays, so I've done some other experiments with like accounting for different ratios, but this is just a quick and dirty solution. So what I do is I check the bounds here with that bounds line, and I get the bounds width and bounds height, and I say, okay, if the width is greater than the height, so like this laptop will be width greater than the height, then I want my big size, which is a constant I'm setting, to be the screen height. So that's how tall the screen resolution is. Otherwise, say if it was on like a phone or someone's using a monitor, vertical, then use the width. And then I set a ratio, and this 600 is a constant that I'm using as like, in my logic for displaying, everything is based off a 600 by 600 display. So that means on my game logic, like moving something up, to the right 1 point, I don't have to think, oh, what's their screen lag? I just say go up 1 point, go to the left 1 point. I do physics calculations, inelastic collisions. I don't have to worry about screen at all. I just say, here, do the math, and you're going, this thing's going over here, this thing's going over here. And yeah, so that ratio lets me then, in my draw code, I basically multiply everything by the ratio. So like here I'm doing a canvas context move to, and I have, I'm moving to a x position times whatever the ratio is, and a y position, which is that start index 1 times whatever the ratio is. And you can see, it's all through here, and I'm sure you could clean this up and make a refactored draw to screen function to include this automatically. But yeah, so you can see here, like I've got that times a is just a that's for drawing a rocket. In this case, it's always going to be 8 pixels long, or 8 units long, and then scale to the screen. So quick demo. So right now, I like the decimator. Nice. Well, it actually might be difficult to show on. I can't change my resolution with. Oh, here I can. Okay. So hopefully this works. That change the res over here? Okay. So, and then I'll test this out, and we should have a square drawn up and filling the screen. I'll quit out and change this to 80 instead, so it's different. I'll run this again, and it's all the same display on my screen. So, yeah, that's pretty much it. Looks like I've got like 2 minutes left. So real quick, I just want to say that Electron is really cool if you do want to make native applications. There's an awesome tool called Electron Packager, which you can compile your apps in like 1 line, and it takes 20 seconds or so. You can look it up on GitHub, but it's really, you just do like 1 second. Run that, and it'll run everything for you. So, yeah, that's it. I've got 60 seconds left, so if you go to quantum. On productions.h.io, and I've got some games up there. You can download and check out the code if you want as well, or email me any questions. Yeah, that's it. Thank you.
All right, now Craig, give you permission. Timer of death is now set.
This already start? That's totally not fair. I'm Craig. I'm a developer at Carbon 5, and I'm going to talk to you about a tool called Razor that I'm almost done building. So Elixir is rad. This is objectively true. Phoenix is also rad. How many people have written Elixir? Cool. How about Phoenix? All right. How many people are interested but haven't gotten to try it yet? Cool. Cool. Very cool. So why and when do we use Phoenix? I like it for large production apps when I care about efficiency and concurrency. You can also use it just for back-end APIs and for prototypes. Most people think Rails for prototypes, but Phoenix makes things pretty easy to the point where you can just slam something up. Then there are game changers like areyousandwich.com. If you're not familiar with this, this is something that I built in Elixir and Phoenix. It is a real app, and it's designed to enhance world peace or something. People argue about whether or not things are sandwiches. And you've got the answer now, so go to areyousandwich.com. So I found that I kept repeating a bunch of setup for all these different Phoenix apps, and I didn't want to do that anymore. So in Rails, Carbon 5 has a project called Raygun that solves this problem for us. So what this does, it basically zaps up a Rails app with a lot of Carbon 5 stuff built in, best practices, tools, etc. So it's a big time saver. If these are the types of things that you're into in Rails, it saves you a bunch of time in setting things up. And it also kind of nudges you towards best practices in terms of testing, continuous integration, stuff like that. It's very opinionated, so if you agree with the opinions, it makes a lot of sense. So for Phoenix now, we have Razor. And I'd also like to point out that logo, which is objectively badass, is made by Mr. Jathan here. Looks great. What's in the box? So this is the skeleton, and what you get is Phoenix, obviously. You get Postgres, which is your Postgres driver. Slim, which is a significant white space templating engine like Jade, or you can use Slim in Rails. Wallaby, written by my buddy Keith Lee, is a integration testing framework. It's kind of like Capybara, but faster and super cool. Ex Machina is like Factory Girl. If you use that, helps you spin up your data and your tests. Yarn, because we're all using Yarn, right? Sass, Bootstrap. There's one problem in Phoenix where the JavaScript stuff doesn't work out of the box. That might be fixed at some point, but in case it's not, you can use this and it'll just work. So you can get your modals and all that stuff for free. Also, Phoenix doesn't ship with an acceptance environment, and at Carbon 5, we do agile development, so we like to have our stuff in front of clients at every step. So this builds in an acceptance environment for you. CI is handled with Circle CI for now. I'm in the process of Dockerizing everything, so that might go to Circle CI 2 or Heroku CI, which is also in beta. And this IEX EXS, which will be meaningless unless you're familiar with Elixir, but when you open up your REPL, this will alias your main app namespace for you. And it's all based on .env configs for deployment and whatever else. So that'll work with Docker or Foreman or whatever you use for that type of thing. Separate repo, this is the Zapper. So we clone the app skeleton, and then we let you apply a name. For example, are you a sandwich? And it'll go and it'll replace all instances of that through your code base, whether it's in the file or the file names themselves. It'll slam up a Git repo for you with no origin, so then you can put it up yourself wherever it needs to go. And then it walks you through whatever setup is left in terms of like setting up a database and JavaScript compilation, that kind of stuff. So you do have to be careful, right? Because this makes things a little too easy. And the Elixir community encourages people to have a really deep understanding of your whole system. Also, Elixir really encourages you to compose things out of small parts. So it's good to have a better idea of what's happening. So watch out that you don't get into magic land where you don't understand what's happening. If you use this, I encourage you to go look at how I implemented everything and use it for learning. So build a Phoenix app and then go backwards and start picking it apart. And then once you have all this stuff under your fingers, it'll save you time on the next app that you put up. And last but not least, this is open source. It's going to be released through Carbon 5's GitHub. And there's a lot of stuff left to do. It's also a great place to have a conversation about what these best practices are. So if you want to get involved, I'm on ChawDev Slack. Just look for Craig Lyons, or you can email me there, or you can come and talk to me. And we will soon have really cool stickers, too. I made it. Oh, I have like 10 seconds left. All right, I'm done.
Flawless, absolutely flawless timing. Incredible. Mr. John Nelson. Are you here, John? I didn't think you were here. Our first lightning no-show. So there's one. Yeah. We're going to shame you, John. This is now and forever. So let's see. Who's actually up next then? How about Wesley? Wesley? Come on up, Wesley. Everybody give Wesley a hand.
There we go. I'm Wesley Reitzfeld. I am a web architect consultant, and I wanted to take 5 minutes to talk to you about Scrum and Kanban, which are two agile methodologies that help you get your work done, or hopefully. In my experience, most tech companies kind of go from chaos to Scrum, and then the lucky few move on to Kanban. So what is Scrum? So Scrum is made up around these things called sprints. I'm sorry, it's a little blurry up there. Sprints are about 2 to 4 weeks long. At the beginning of each sprint, you meet as a team and you plan all of the work you're going to do that sprint. The team commits to the work, so they're kind of saying, hey, we're going to get this chunk of stuff done in these 2 weeks. Scrum consists of daily stand-up meetings every day. Daily stand-ups are a way for you as a team to talk about what you did yesterday, what you're going to do today, any blockers, and general coordination. At the end of every sprint, you have a retro meeting. So retrospective is a time to go over what went well, what went poorly, and kind of fine-tune the process. Some of the pros of Scrum are that you're supposed to have a shippable product at the end of it. So at the end, all of the work that you said you're going to do should be done, and you can ship. There's no half-written features. You're not supposed to be disrupted during this sprint. So product owners or other stakeholders aren't supposed to interject work into your pipeline. They're not supposed to interrupt and say, hey, actually, I want this done. Leave the team alone. Let them get their work done. Daily stand-up and retro meetings are awesome. They're a great way to coordinate and a great way to fine-tune the process. Some of the cons that I particularly have with Scrum are planning meetings can be big. If your sprints are a month long, then you are meeting as a team and trying to figure out what you're going to do that entire month. Bleh. There's no room for investigative or research tasks. Oftentimes, let's say you have a bug that you want to plan. Is it a one-line fix, or is it an SDK change that is more involved? Don't really know, and you're supposed to estimate on your lack of knowledge. Good luck. These last two, so carryover and stretch goals, to me are a sign that this process is broken. They're kind of Band-Aids on it. Carryover work is, at the end of the sprint, you're not going to actually have finished everything. It's kind of rare, so that work's going to be carried over into the next sprint, which starts making you ask the question, why are we even doing this? Stretch goals are a way to work around the problem, the inverse problem, which is you get to the end of the sprint and some of your engineers are freed up and the current work remaining is in progress and there's no work planned. So what do? So what you end up doing oftentimes is allocating stretch goals. So you plan your sprint and you also plan a set of stretch goals for people to pick up if they run out of work. So introducing Kanban. So Kanban, as opposed to Scrum, is a continuous workflow. Work progresses from the backlog to your pipeline to being done. You plan tasks when you need to. Kanban also advocates setting mins and maxes on your columns. So this is a way to limit how much work you have in progress and also make sure that you always have work to do. Pros, continuous deployment. When things get done, go ahead and ship. Smaller and more frequent planning sessions. And it's easier to discern task priorities. So we'll take a look at a fake example. So here is whoa, it's really blurry up there. A fake Kanban board using Jira. I'm not the biggest fan of Jira, but I think they do a good job with their Kanban board. So a couple of highlights. This is very similar to what a Scrum board might look like on Jira. A couple of exceptions. We added, when my team switched to this, we added the planning column here. So planning is a great way to give your engineers a chance to really craft the story and make sure it's ready. So this is where back and forth with designers will happen. This is where you might do some design docs if you're trying to figure out implementation details. This is where you could investigate bugs and find out their root causes. Once we're done with that, it moves into ready, and then it's ready for an engineer to pick up and run with it. A couple other interesting things. Just looking at this, you can see that the in QA is red. We have 4 in QA, and a max of 2 is set. So this tells the team immediately that, hey, we should get QAing some of these stories. They're basically done. Let's QA them, get them in deploy, and get them out. The other thing that this highlights is the ready column. Ready has 2 tasks and a min of 3. So this is saying, hey, we need to do some planning. We need to get some stuff from here to here to here so that things are ready for engineers to pick up and run with. Personally, I love this. I think it's a much easier process. It just feels more natural. As a team, we ended up doing this plus keeping stand-ups and retros because they're very good at coordinating. Yeah, and if you're using Scrum and you feel like the process isn't working, please try Kanban. It's awesome. Thank you.
Everybody give a warm-up clap to Andrew. Ooh. Already getting heckled. Ooh, rough crowd. Talk to a therapist, Andrew, not us. Hi, when I have this lovely group of people. All right, so hey, I'm Andrew Rogers. I help run JawDev with Brett, and saw that there was still a few slots open, and I've been working on this project and thought I'd talk about it. So we'll talk about tracking Bluetooth devices for urban insight or fun and no profit, but maybe fun. So this all started with a challenge. I was down in Lafayette, not Lafayette and not Lafayette, Louisiana, and talking to one of their traffic engineers, and we're talking about technologies that use Bluetooth to track segment times and traffic flows through cities. And Chattanooga has a few of these devices. They're from a vendor. They're like $4,000 to track and sniff traffic off of vehicles driving by, and then figure out how long it took to get from one point to the other. And he said, it's just a few lines of Python. Like, get some Raspberry Pis and do this. Like, that's what we do. It's $100 or something. So I was like, am I letting a traffic engineer tell me it's just a few lines of Python? Like, this, I got to dig into this a little bit. So I did, and I'll stop here and talk about a little bit about why. So Bluetooth is ubiquitous. I did a little bit of research last night, and literally they ship 4 billion devices enabled with Bluetooth every year. That's freaking incredible. So they're everywhere. A lot of them are just on and broadcasting their Macs around, and you can just sniff them. Communications of any kind require some way of identifying the reason why they're broadcasting their Macs, and we can sniff that identification to detect unique devices.
And then someone in the crowd says, well, what about privacy? And the cynic says, turn off your Bluetooth. But I'm trying to, my position on this and my approach to this is trying to build some tools that, A, unlock this data for cities, B, open up the data to where, create an open data source and create a streaming open data source that will allow developer communities to engage with city data that might be more interesting than what's available now. So the constraints I have on approaching this project were I needed a real-time capable API to access real-time dashboards and stuff like that, but I also wanted to make sure that there was some privacy. I'm going to show you a little bit about what this looks like. All right, so this is actually a device I installed Monday on the ground floor of this building facing Market. So you can see that it has observed 10,000 devices in 3.5 days. Of those, there were 7,000 unique devices. This is updating in real time. You just saw that change. This is actually, I forgot to change the header here, but this is in the last hour. So the number of devices seen in the last hour. And you can see here, this is over the last 4 days. You can see, and there's the dates, you can see some sort of daily patterns emerging, although this isn't enough data to really make huge analysis from, but it's starting to look interesting. So that was the real-time side of it, showing up in Grafana. And how do we protect the privacy? So hash at collection, but even that isn't really good enough, because if you store hashes or a unique identifier for a device and you get a month or 2 months worth of data, it becomes pretty trivial to identify exactly who that is based on patterns. So to get around that and to maintain the real-time ability, and also to get, I thought it was important, you can open the data as like there was a trip between this point and this point, but I thought it was kind of important for real-time applications to be able to say, I saw this device at this location now. So that was at these 4 other devices. So what we do is we assign an arbitrary expiring UUID that is actually what is stored and what would be released on the API. Right now I've got it set up where it stores it for 24 hours. After 24 hours, if it sees the same MAC address, it assigns a new UUID. So you can track traffic over a day pattern, but you can't track long-term traffic. So this is what some of the analysis I did as of this morning from data. This is just a histogram by minute, which is pretty noisy, but you can see that there's some peaks, like people coming into work around lunchtime, and then 5 p.m. people leaving. This is that data in binned in hours, so it's a little easier to see those peaks and a little less noise. And one of the things I was curious about was just how much noise is there, how much of it is like me walking in and out of the building. So I did this little plot. So this is the top 500, or the top 500 devices in order of how many times they were seen. And so you see there's like one up here at 84 times, which means it's like right out of range and kind of goes in and out, and so it's being seen a bunch of times, but it immediately falls off, and you begin to think that probably somewhere around here you're seeing actual real data. The way I mitigate this for the most part is I have when it sees a MAC address, it stores it locally with a timestamp, and it does not, it won't register that as an observation until it hasn't seen it for more than a minute. But there's still obviously somewhere at the edge of the range, there's some flapping happening. So next steps, obviously deploy multiple nodes. So I'm going to put these around town in different locations. I think one of the other problems with this location is I can't really tell the difference between road traffic, vehicular traffic, and pedestrian traffic. There's so much pedestrian traffic on Market out here. So putting some in places that are pretty much only accessible by cars would be interesting to be able to correlate and figure out what here is cars versus geotagging. Right now I'm just kind of storing the location as a name, a friendly name, but eventually this will have, I already added the field to the database and I'm populating it, but I don't have any tools to kind of display heat maps is what it'll end up looking like across, and then the WebSocket API. So I'm getting the data in real time, but I'm not really, it's going into a database that's being queried by Grafana. It's not really going straight out to an API, but I will be implementing some sort of WebSocket API for any developer to connect and use the data. And then probably start internally tracking segments and times between segments, just because for some people that's probably all they're interested in, specifically transit folks, but still maintaining the ability to kind of look at devices arbitrarily. If you want to look at it, I just pushed it up. This is just the code that's running on the Raspberry Pi that's collecting the MAC addresses and then shoving them to a REST URL. I'll put the server up there once I get it cleaned up from hacking. It's all pretty rough right now, but and then it's just a few lines of Python, so that's the best part about it. So thank you. You can find me in all these places, and that was Bluetooth tracking for fun. And that's it for CHA-Dev. So no more lightning talks. We'll see y'all next week, or you'll see Brett next week, because I won't be here.